Let's start for today. So today basically our main target is we'll be quickly giving the overview what we have learned in the last two session, right? And then finally our objective is to go through the logistic regression, right? So let us quickly go get an overview what we have learned earlier. So first thing is that we discussed about the human intelligence, right? Where we know that the machine should have the similar things like human input, memory, processing, prediction, decision, action, feedback, and by that machine gets learned, right? So that is what we have learned. Then what we have studied is the next thing is the machine learning should have an input and it has an output, right? But we are actually applying different algorithm models, right, based on the use case to to achieve the output actually. So applying the particular model is very very important when we'll be getting the use case. So based on the use case, say for example, I'll give you two examples. So if you need something to predict continuously, right? So like what is the weather forecast, what is the the speed of the wind in a particular time. So this is something which you are asking machine to predict, right, which is a continuous thing. Then you will do the regression, right? So linear regression is one of the examples which we have learned yesterday, and it is very very simple. It is the concept of y equal to mx plus c. That means you are just drawing one line, right? And your input is x and c, and based on that you are getting y. So you are plotting that informations over there. Now your baseline is y equal to mx plus c, whereas you whatever output you are getting, you are actually calculating the distance. That is, the distance is lesser than the distance, your model is good. That means your error is less, your accuracy is good, your precision is good, your recall is good. So this accuracy, precision, recall, these are the different metrics which are used to finalize a particular machine learning. Okay, so you are giving input, you are getting output, but there are different AI algorithms which will be applying it to make that model perfect. That is our idea. That is why we need to understand the use case. Say for example, if the use case will come like, okay, can you predict a house price, then you will go to the linear regression, okay, because it's a continuous. But if anybody says if that person has a diabetic or not, right, I should do this work or not, then you will go to the logistic regression. That time you will not go to the linear regression. When you want to get your definite answer 0 and 1, that time you will be going to the logistic regression. It is a part of classification, it is not a part of regression. So we know that broadly, Angshuman, we know broadly there are two things. One is classification, another is regression. Regression means continuous. Classification means if you want to categorize the things. When you are trying to categorize the things, that time it is the logistic regression algorithm which we can use. Okay, understand? So now quickly going to the today our topic is to discuss about the logistic regression in details. Right, so machine learning algorithm data model which goes to the inference model. Okay, and we said that these are the two things, right? Under supervisor learning we are talking on the supervisor. So regression, as I said, linear regression, please go through from the previous video, and the classification which we will be talking today, and we'll be getting more informations how the logistic regression works. Okay, now what I want to clarify here is, see, I am telling logistic regression, but I am not telling logistic classification, right? That is very interesting, because here we are saying that linear regression, but here we are saying a logistic regression, but the logistic regression is part of classification, right? So that is why I will be explaining today why it is a logistic regression, not a classification. Okay, when we will be going in details, you will be come to know. Okay, now these are the things which we have done. Very very important picture is this one. Basically what we have said, that when any kind of models which you do, training the model is important. How we are training the model? See, here we have a label data, and from there you have a label data. What we are doing using that algorithm, we are actually differentiating that which is the cow, which is the elephant, and which is the camel, right? And based on that, we are getting the output. So supervisor learning is always go with the label data. That means you are giving the input and you are learning that machine that by saying that if this kind of animal will come, right? If this kind of animal will come, you will always predict this is the elephant. If this kind of element is come, you'll always tell it's a camel, right? So this is how you are actually doing an algorithm by which you are actually saying that this is how you need to respond. So this is what we want to classify. So in the under classification, logistic, linear, all these things are there. So we'll be today's our target is fully on the logistic regression. Let's not waste any time. Let's go to the logistic regression now. Any questions? I hope you got the gist,
Yeah.
right, Angshuman?
Yes, Sapirji, yeah.
Yes.
That's
Okay. Now I'll be going to the directly to the logistic regression. Please go through the linear regression in details. It is very easy and you will be easily understand. Anybody can understand. I have guaranteed to this forum that AI is the most easiest subject in the world. Only thing is that we need to know. That's the only thing. Very, very easiest subject and we all can learn it. Okay, now let us go to the logistic regression. It will not take much time. It is very simple and we'll be explaining it in details. Okay, so this is the logistic regression. So question is what is logistic regression, right? So first of all, it is part of a classification. Always remember it does a category, right? It does a category. That means it is yes or no, 0 or 1, true and false. This kind of information it gives. What are the examples? Very, very important example, right? Will a customer default on a role? Yes or no, right? That is the point number one. Second question is, can this customer get a loan? Right? That is again yes or no. Is this person diabetic? Yes or no. Right? So those kind of information you will be getting. So that means you understand from here you are asking machine to predict something and it is almost definite. That means how it will be doing, it will be doing using the it will predict using the probability. So very, very important, when it predicts something, it predicts based on the probability. So 80% chance. That is why when we'll calculate on a machines how the performance is, there are few metric which we calculate. One thing is what is their accuracy, okay, what is their precision, and what is their recall. So we'll be having the one next session when we'll be discussing about those parameters in details. But for a moment you just mention that the more accuracy of a model is, the more the model is good. But this accuracy only worked when you have a getting the balanced data. If you are getting non-balanced data, then accuracy will not give the right result. Okay, accuracy will not be a correct parameter to identify if that machine is perfectly or not. So I'll be explaining more details in the next session. But for a moment, we need to understand that it is a 0 and 1, 0 and 1, true and false, which we are getting it from here, right? So this is what the logistic regression in the industry. We use this logistic regression for fraud detection, spam email detection. In Google, if any email comes, it actually determine if it is a spam or not. So they use this logistic regression methodology actually. And then the disease prediction. So these are the main use case where we are using the logistic regression. Any question?
No, Sapirji, that's fine.
Very good. Very simple things, right? Okay.
It's like
Now,
when we have a definitive answer, yes or no, or like in
yes,
binary.
yes. Now you will see the very interesting thing why we are saying it. So let us go through this. Then means when I'll be going in the deeper, you will feel what is the beauty of this language. Okay, why it is so simple. Okay, so let's double click on the logistic regression. So my question was why logistic regression is a classification model. Very, very important. Okay, so we know that in supervisor learning, just a background, who has joined just now. So we know that in supervisory learning, there are two main parts. One is regression, another is classification. Under classification, logistic regression comes. We say it's a logistic regression. We don't say it is it is not a logistic classification. So this is the interview question. Why we'll be calling it as a logistic regression, not logistic classification, right? So what is the reason? So basically, the main reason is using the word logistic regression we use because we predict anything using the probability. That is the main thing. And probability, what is the probability is? Probability is not a continuous value, right? Sorry, probability is a continuous number. Probability is a continuous number. It predicts probability. It predicts probability, and that is the reason. And since probability is a continuous number, we call it as a regression. Okay, and always remember the output of it is always between 0 and 1, and the output represents the probability of belonging a class. Okay, now what is this mean is, if the probability greater than 0.5 will get, then the class is yes, and if the probability is less than equal to 0.5, then the class is 0. Okay, always what we need to remember that during this logistic regression, the value will be always in between 0 to 1. That is the main point. In logistic regression, when we have learned the linear regression in the previous session, we have seen that it comes like 80%, 90%, we calculated R square value. But in logistic regression, the value should be always between 0 to 1. Okay. And that is why we'll be learning in few minutes what is a sigmoid function. Okay. And that sigmoid function actually helped us to calculate always in between 0 to 1. Okay. Now see here, what we are saying that if probability, so 0.5 is what? 0.5 is within between 0 and 1. And what we are saying, if it is more than 0.5, then you say it is 1. If it is less than equal to 0.5, then you will say 0. That means if how it will be calculated, very simple. If I am a diabetic person and if that model has been asked to calculate if I am diabetic or not, based on the training data, if it calculates that the probability is coming 0.6, then the model will say, yes, I am diabetic. If it is coming less than 0.5, then the model will predict, no, I am not a diabetic. That is how. Okay. As simple as this. Now, this is the sigmoid function, how you will calculate. So, why this sigmoid function comes, I will be explaining. Don't worry at all. Okay. What we are saying that 1 divided by 1 plus e to the power minus x. This is the sigmoid function by which all the time you will get the value of 0 and 1. Okay. Now I will be explaining where from this function has come. Why we are going ahead with this function. There are reason. Okay. So I'm going to my picture here. Okay. Look into it. Right. So what we are saying that all the time we want to get the probability, right? Probability of y equal to 1 or probability of y equal to 0. Y equal to 1 means if the person is diabetic. So what is the probability? So basically we are asking, okay, this is the guy X, he is standing in front of us. What is the probability he is a diabetic, right? So that means y equal to 1 based on the some input function. Now we know that mx plus c equal to the number of the linear regression. Now if we use this linear regression formula, what will happen? We'll get the number 5, right? So if x value is equal to 1, then you put it to 2x plus 3, so it will come as a 5 value. Then this 5 value is not between 0 and 1, right? So that is the reason this mx plus c, which we use the linear regression time, it will not work. Then what will work? Then what will work is this sigmoid function. Now you see the beauty. So what we are saying, the sigmoid function calculation is 1 divided by 1 plus e to the power minus mx plus c. Now if you put 5 in x, right, then you will get e to the power minus 5. Right, so 1 divided by 1 e to the minus 5. So always it will get 0.95. So 0.95 means exponential. When you are taking the exponential of this value, it will be always come between 0 to 1. Right, it will always give the 0 to 1 value, and that is what we are saying. So 0 to 1 value means if it is more than 0.5, then what is the class, sir? The class is 1. Right, that means he is a diabetic, or it is a fraud, or it is a spam. Right, or if it is less than equal to 0.5, then it is not a diabetic, not a spam, not is. So this is the reason, this is the formula has came. Am I clear? Am I clear why for
Yeah.
logistic regression we are using these values?
Okay. So for logistic regression, we need to have that linear regression value as well, right? To
No,
calculate that probability. MX. plus C
Correct,
was linear
correct,
regression.
correct. So mx plus c is so in linear regression, Angshuman, what happens? You are predicting something. So if your
Correct.
use case is predicting something, then you just go ahead with the y equal to mx plus c and go for the linear regression directly. Okay, which is continuous. Predicting something which is continuous, then you go to the linear regression. But if you want to do the categorize, basically you are saying, okay, you need to tell it is a fraud or not. You need to tell that. Okay, you need to tell that it is a spam or not, right? 0 and 1 answer. Then you need to go to the logistic regression. And in the logistic regression, to make it 0 and 1, we need to get the number between 0 and 1 only, right? So that is why we are going with that sigmoid function. It's very easy, right, Angshuman? Very
Yeah, yeah.
simple and easy, correct? Or you have any question, any doubt?
No, 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 that is fine. Yeah.
Very simple, very simple. And that is why this function is. So we'll never forget why mx plus c will not work for this logistic regression, because it is giving 5. And we are looking for some value which will be 0 to 1, so that we can get our proper class, right? That is the reason. Proper class means 0 and 1.
Yeah,
Now,
yeah.
yes. Now let us go to the little bit more. Now suppose if you have the multiple input, right? Then same like earlier, you need to do e to the power minus m1 x1 m2 x2. So if you have a multiple input, multiple x values, then you will be going with that, and from there you will be getting these values, right? So this is how we are doing actually. Okay, make sense?
Yeah, yeah.
Yeah. Okay. Now let us go to this. So now the problem statement. See, you want to predict whether a person will buy a product or not based on the age and salary, right? So now you calculate this and you go for this logistic regression, right? And you find out 0 and 1, and based on that you will be informing your marketing team that this person, there is a high possibility this person will buy it, right? And based on that the marketing team will go and give the different tariffs or offer, etc., so that this person will purchase that particular product. Make sense?
Yeah.
Okay. So why it is not typical regression? That's what we explained, that it is a classification, because classification means it is categorizing the thing, means 0 and 1, right? It is not something continuous like house price, like the
Mhm.
wind temper or the temperature, right? Which is continuous, but it is a definite. You are asking definite, right? Spam or not, loan approved or not, disease or not, like that. Okay, that is why we are saying it is the classification. It is not regression, but although the name conveys the regression, because we are doing the probability, which is a continuous value. Probability is a continuous value, hence the name regression is there. But actually algorithm is actually finding out 0 and 1, and that is why it is a logistic regression. That's it. Okay, so we
Yeah.
just covered that logistic regression today. Any question?
No, no, sufficient.
Okay,
That is
fantastic. I'll stop the recording now.
fine. Mm-hmm.
Okay. So in our next session, what we'll be covering, right? So suppose we build a model, right? And after building the model, how we will be checking that model is working fit for the purpose or not. Very important, because you are predicting something. It is not the accurate result which you are getting. That is very important here. In production, when we worked in the
Yeah,
data,
yeah.
right, we always get the accurate result. But in the model world, it is a prediction. How close your prediction is with the actual, that is what, right? So we calculate three more things which we will be talking in the next session in details. One thing is called accuracy. Okay, accuracy only worked for the balanced data. I said just previously. Balanced data means, and what is unbalanced data? Say for example, you have draw a line, and in the left part is the actual and the right part is the prediction. And in actual, 90% you said that is the not cancer patient, and 10% you are saying that it is the cancer patient. Okay, now when you are giving the prediction or the output, right? So you are showing that the 90% means all the result which you are getting, right, prediction, all it's a 0, right, means there is no cancer patient. Then it is not a balanced data set actually. So balanced data set is where it will be segregated properly. And in this context, I want to call out there are two kind of data. One is the training data and is the test data. Train data should be generally 70% and test data is the 30%. When any model gets trained, the model is get trained with the train data, not with the test data. So you train the model with the train data, and with the test data, you will check the performance of that particular model. So that is the idea. Okay. So by that way, what will happen? The model will be the model will be fine tuned, and it can actually tell to the developer if it is correct or not. So one is the accuracy. So accuracy should be good. It's for the balanced data, but if it is data is not balanced, is the unbalanced data, then you need to check the precision, and another thing is the recall. So precision and recall will help you to identify that if it is the proper data or not. Okay, for that we will be learning what is false negative, what is the false positive, what is the true negative, what is true positive, etc. Will be will be learning, and from there we'll be deriving it. So as simple as this. So these are the way we can define the model, and then we'll be learning what is the KNN model, right? KNN model is means high level. I am just quickly telling today. KNN model is it always check with neighbor, right? So for example, if I am staying in a society, and in my society, suppose COVID has come, very unfortunately, don't take it otherwise. So COVID has started, and what we have observed, that very nearest person, very nearest neighbor of me is identified as a COVID. Then the model will predict to me that this guy will also undergo COVID. So that is how it works actually. If my neighbor who is staying further, right, means very far from me, and if he has a COVID, then there is a less possibility I will have a in the model will predict that I have a COVID. So this is how the KNN is. KNN is know your neighbors, right? By which it will predict the things. So this is the beauty of the KNN. Then we'll be learning about the decision tree. Decision tree means it's the like if else logic by which we'll be going to the homogeneous result, and we'll be finding out if that result is correct or not. Then we'll be learning about the random forest. So this is the way we'll be learning most of the models algorithm. But most importantly, what we need to know, we need to know high level how the model works, and we need to identify when any use case will be given, we need to identify that which algorithm I should use. And to be honest with you guys, that the Python code is very, very simple. And for all the models, the Python code is same. Okay. So I'll be showing a Python code to you as well. And the framework of the Python code is same for all the models. You just need to bring to the different model, and you just need to try it. So as simple as this. And how it works in the industry is, look, it depends on the one is the use case, another is it depends on the data also. Like I said, by I said couple of things like precision and recall, right? So you don't know how the data is, because there is a billions of data, right, or millions of data which will be giving, and you need to train the model. So hence, what industry generally do is, when you build a model, right, you need to test with all the algorithms, and then finalize which of the algorithm will be. Now there are 20 algorithms, say you will definitely not go 20 algorithm. You need to based on your use case, you can reduce it, say 5 algorithms, and then test that 5 algorithms with full data, see which is giving the best performance, and then you can go ahead with that. So this is how the industry works. Hope that makes sense. Okay, so makes sense, right, Angshuman?
Yes.
Yeah. Okay. Now I'm stop recording.